Welcome back to Westwood High School. We're in precision manufacturing today talking about linear and circular interpolation, or essentially how do we program motion in a CNC machine. So let's get rolling. Our central question here and the essence of this presentation is we're going to discuss how we control CNC motion for milling operations specifically. Now, a lot of this will carry over to the lathe. We'll cover that at a later time, but for today's purposes, we're going to talk about movement in the X, Y, and Z axes of a CNC mill. The objectives, what I'd like you to learn out of this is I'd like you to learn how to use and define the terms within a linear interpolation commands, both a rapid motion command and a linear feed command. I'd also like you to understand the terms that define circular interpolation commands. And all that means is I'm going in an arc. And there's two ways we can define the arc center. I can do it with an IJK method, or I can do it with a radius method. We'll discuss both of those, and you should be prepared to be able to use those in our follow-on exercises. So before we get started, let's talk about a typical CNC mill, vertical mill, axes. And you'll notice that the Z always aligns with the spindle, so positive Z is up, positive X is to the right, positive Y is away from you as you stand in front of the machine. The image to the right, where my cursor is flashing, this is essentially what our Haas VF2 mill looks like if we took away all the covers and it was just sitting on the floor without its enclosure around it. So X, Y, and Z. Now that's not changed from the knee mills that you used last year. The first linear movement command that I want to talk about is a rapid, and that's G00. Now, as you remember, all of the G commands are preparatory. That just means it needs more information. And in this instance, the G00 is a rapid movement, and it moves as fast as the machine and the override button will allow. So if you're in 100% rapid, you're somewhere around 1,000 inches per minute on our machine, pretty darn fast. And we use this whenever we're not cutting. And I've got that as the last condition, non-cutting movements, but really there's a few times that we're never cutting. One is during a tool change, another is during a home command, and then anytime we're just rapiding around the part. So when we rapid, we always want to be careful that our tool is clear of the part. If your tool is not clear of the part and clear of the fixtures that hold the part, you're going to run the tool or the spindle, worse yet, into a component that's not going to want to move, and you're going to break things. Now, the way the tool moves, because I can command this in three axes, X, Y, and Z, initially it moves at a 45-degree angle in all axes, and it does that until it hits the longest axis. And then it's going to move along that axis until it hits its destination. So it kind of moves at a 45 initially, a little bit unlike a G01. Now, if we talk about G01, linear interpolation, we're talking about moving in a straight line. And the G01 commands basically have an X, Y, and Z command, and then a feed rate. Now, this moves at a prescribed feed rate in all three or only one or two of those axes at a time. Now, the feed rate in our machine, we typically are using inches per minute. That's set by our G20 command, which we use for our safe startup and also the default programmed into the machine. And I can set that either as inches per minute. That's typical for a mill. I could also set it in inches per revolution, very non-typical on a milling machine. So we're always in inches per minute. Now, there's four little diagrams down here at the bottom. The first one is pretty straightforward. I'm just moving in the X direction. So you'll notice that the command that is given tells it where it's going to. So in this instance, I started over here on the left, and I moved to X 3.0. Here's a Y movement. I start at the bottom, move to Y2. Here's a combination, and you notice it does an exact straight line to arrive at exactly that point. So I start on the left edge over here, and I'm commanding X1, Y1 for motion. And here's in three dimensions. I'm going X3, Y1.75, and I'm reducing or cutting down in depth to Z.25. So I can move in three dimensions with that command. Very handy. We'll use that all the time. And remember that G01 command, the destination I given that in X, Y, and Z, is from its current position, and you're telling it where it's going to. It'll only move the axis that's commanded. So if I say G01 X 1.0, it's not going to move the Y, it's not going to move the Z. And all of the axes commanded are simultaneous in a G01. That's not like the rapid. G01, they move them all simultaneously to do one straight line that goes to the point. Got to have a feed rate in here, guys. If you don't have a feed rate, if you didn't give a feed rate, remember that our feed rate, the F word, is a modal command. It will stay at its last given feed rate for all subsequent movement commands. So the big question here is, what if I don't give it a feed rate at all? Well, if you don't give it a feed rate at all, if there's no feed rate in the machine, it was just started up, it's going to give you an error code and turn on the red beacon. But more importantly, if you have a very high feed rate because you're doing something and then you don't adjust that down for a deeper cut or a different cut, it will just use that last feed rate. It's a modal command. So that's how we move in a straight line. Well, how do we move in a circle? And the answer to that is G02 for a clockwise arc, G03 for a counterclockwise arc. Now, very much similar to the G01, we give it a command where it's going to move to, but I need to give it a little more information. So before we talk about that information, let's talk about our axes relationships. And you may remember this when we were talking about introduction to CNC motion, is I've got X, Y, and Z. Well, we're all familiar with that. I've also got a couple of axes, I, J, and K. Those are incremental moves in the X, Y, and Z axis, respectively. Now I have the third ones, the rotations, which we won't use because we don't have our rotary installed. That is A, B, and C. So I can rotate around the X, Y, and Z axes also. So the motion that we arc in, we're only really ever arcing in two planes. And we set that with G17, 18, and 19. That tells us what plane we're going to arc in. We'll talk about that here in a minute when we look at some examples on this. So when we talk about circular interpolation, what we have to address are the following terms. We need to tell it where it's going. So G02 is the preparatory command, needs more information, needs a destination in X, Y, and Z. Now, similar to my G01 commands, these are where I'm going to. But I need one more piece of information. I need a radius here, or I need to tell it in terms of I, J, and K, where the center of the circle that it is arcing on is formed. So IJK replace the term R. I use one or the other one. Now, an example down here, you're going to see this G01 example, and this is straight out of our book. So G01, I move linear interpolation. I'm moving to the left here to X minus 1.5, and I've stopped at this point. My next command is G02. Two ways I can do that. I tell it G02, here is my finish position. My finish point or my arc end point is minus 2 in X, 1.5 in Y. And then I can tell it, hey, use a radius of 0.5. Now the other way I can do that same command is I can say G02, same destination, X minus 2, Y 1.5. But now I can tell it incrementally from my start position, I'm going to move up in Y 0.5, or the radius, positive 0.5. An incremental move in Y is a J move. So I type in here J.5. Notice I don't need to put in a I0 or a K0. I just need to tell it incrementally where is the center of this radius relative to my starting point. So that's the IJK method. We'll use both of these. They have advantages and disadvantages, which we'll discuss as we do our projects. And here's the IJK, the real answer, why we use IJ sometimes instead of R. And you can interchange R and IJK as long as you're arcing less than 360 degrees. It doesn't matter.
It is useful to use the R sometimes because the math is a little easier. But I will tell you that the IJK method always has more control over the arc. You won't get weird, unexpected results if you use the IJK method. Now, one thing to remember is a R number for the radius is only good up to 180 degrees. If I have to go more than 180 degrees, then I put in the R value as a negative. Now, that's only good for less than 360 degrees. And the reason for that is this diagram to the right. If I use an R method from a start point to a finish point, and I'm going to go 360 degrees, I'm going to start and finish at the same spot. There are infinite number of arcs that I can do to have that happen. So a 360 degree solution, you got to have IJK. You can't use an R. It just won't know what you're going to do. So that's the difference between IJK and R. So now let's go ahead and take a quick look here at these planes again. So as we look at our mill, and we're looking down at the mill, and we're standing right in front of the mill where my cursor is flashing here. Actually, we're standing right here, sorry, where my cursor is flashing. And this is our normal machining method. We're basically machining in X and Y, and we're arcing in X and Y. Now, if I wanted to arc in the XZ plane, I'd have to set G18. This is modal. If I wanted to do the YZ plane, I'd have to set G19. It's modal. So what we typically do is we typically set for XY plane arcing when we power up the machine, and then we are using IJ for our arcing paths. On a lathe, we typically set it up for XZ plane, G18, and we use IK. So your use of IJ, IK, JK has to align with the plane selection. Now, one thing that sometimes confuses students a little bit is I can still move in the Z-axis when I arc. I just can't do a three-dimensional arc. I can't do an arc that is arcing basically in 3 dimensions. I'm arcing in 2 dimensions. I'm changing my depth in a 3rd dimension is the best way to think about that. So let's look at some examples for G02. Here's an example straight out of your book. And we talk about motion right here. So we G00X or G00X1, Y1. We wrap it over to the starting point. There's my starting point, X1, Y1. I am now going to plunge to depth. So I go G01, Z minus 0.125 at a feed rate of 9. Now my tool is cutting. And now I want to do an arc. And my arc starts from where my current tool position is, where my cursor is flashing. And I tell it the finish point, X 2.7, Y 1.7. You come over here and you can see that. Now, I can tell it that the center point is actually 1 inch over to the right from my starting point. So remember, I is X, J is Y, K is Z. So that would be a I positive 1 point. I don't have any offset in J. It's level with my start point. And then I give a feed rate. Did I need to give a new feed rate? No, but I probably want to go faster than 9 inches per minute because that was a plunge feed rate. So that's pretty straightforward for the G02. Let's look at a G02 for a full circle. So here's a full circle G02. And the first thing you're going to notice is that our start point and our finish point are the same. So I rapid it over to X2, Y0. Here I am, X2, Y0. I plunge to depth, 1/8 of an inch down, minus 0.125. And now I'm going to do a circle that finishes, or an arc that finishes at X2, Y0. Now in this instance, I give it an I. There's no movement in X, so my center of my circle is directly above my start point. So I is 0, J is that radius 1, and the feed rate is 18. And it will cut this entire circle around and go to its finish point. Let's look at a couple considerations for this IJK. So a couple things that we want to think about here is that we're always looking for the incremental move over. And here's one that you'll have to do a little trigonometry on. We've done this already, again, right out of the book. So if I wrap it over to my start point, x1.3 and y.3, and my center of my arc is at y equals 1, x equals 1, I now give it the G02 command, which is a clockwise arc to the finish point, same as my start point. And now I tell it that the I movement, which is in x, is 0.7, and the J movement is 0.7. So to go from my start point here to my center of the arc there, I need to move over in the x direction, positive 0.7, from my start position, and up 0.7 from my start position in y. I is x, J is y. Piece of cake. Okay, so could I have done that with an R value? I sure could have. Easy. And in this example, I go to the start point, x1.3, y.3. And now I'm going to end at x3, y1. So here's my start point move, my feed to depth, and my arc. G2, it is a clockwise arc, finishing at x3, y1. And now my radius is minus 1.0, and that's because the arc is more than 180 degrees with a feed rate of 18, right there. If I was going to do this with the IJK method, I would come back here and do a very similar thing. Start point is the same. Feed to depth is the same. G02, X and Y position are the same, except now I'm going to tell it my I position. The X value I'm moving over is 0.7. The J position I need to move over to find the center of my arc, is positive 0.7, J 0.7. And same feed rate. So two different ways to command the same motion. So we're going to go into our workbook, and we're going to do a couple of exercises, and then what we're going to do is come back out and do a third exercise here on our handout. So quick recap, remember that the motion commands G00, G01, G02, and G03 are all preparatory. Remember they are modal. And then the last thing to remember is that an arc needs to have an endpoint and either a radius defined by the term R or a radius defined by the location of the center point in incremental movement from the start point. Either an I value if it's an X movement incrementally, a J value if it's a Y movement incrementally, and a K value if it's a Z value incrementally. That's all there is to it. Let's go to our exercise. Thanks for watching.